Right, today is March 4th, and we're looking at reviewing for the test, pre-calculus test over Chapter 2, which is mostly having to deal with polynomial functions and some stuff on quadratics. So first off, one of the things about quadratics is this is standard form, a times parentheses x minus h squared plus k, and remember the inside liar, where the vertex occurs at the point h, k, and then this is general form right here. And you may have to put problems in the sense into both forms in order to come up with the answer for these here to solve the following equations. So first thing I want to talk about is this, though. Look at problem number 1. Problem 1 has this: x plus 4 squared minus 3. Okay, and you're asked to find the vertex, the y-intercept, and the x-intercept. The first thing I would do is probably do the following. First off, I'm going to want answers in a sense to me in both formats. I'm going to make it easier to find it if you can do both of these here. I'll also show you a shortcut how to particularly find that right there in a second. But one thing I would do is this. Look at this one here. Do I know the vertex already?
Yes.
Yeah, this one's already in standard form, so the vertex, remember this is h and this is k, but this is an inside liar, so the h is not actually what? Plus k, plus 4, but what?
Minus 4.
Minus 4 and minus 3. So there's the first part of the answer on number 1, finding the vertex. The next thing I would probably do is the following. An easiest way to find the x-intercept and the y-intercept. Now one thing you can do that's really easy is what? Go to your calculator, put it in your y equals button, and find when x is 0 what y equals. That would be super easy to do, right?
Mm-hmm.
And you could also find when y is 0 what the x values are, which would be a way to kind of cheat and do it, but I want to show you how to do it without using like the calculator. And without using the calculator, what I would do is this. This is written in standard form. I would go ahead and write it in general form. Or, I'll tell you what, actually, you know what would even be easier? I want to find the x-intercepts. What's the y value? Remember, this is f of x equals correct. What's the y value right here? Find the x-intercepts. The easiest way will be to do this. 0 equals x plus 4 what squared minus what? 3, right? Guess what I would do with this 3? Add it to what?
To 0.
Add it to the other side. So add 3, so 3 equals, and now I have basically x plus 4 squared, right? How can I get rid of that squared? Square root it. Because if I was to square root it, right, these would cancel out. Now, I technically have plus and minus the square root of 3, correct? Equals x plus 4. So guess what I have to do with to get x by itself? Guess what I have to do? Just what? Minus what? Minus 4 from each side. So x would equal negative 4 plus or minus the square root of 3. I have just now found my x-intercepts. My x-intercepts occur at negative 4 plus or minus the square root of 3. There's where the x-intercepts are, because that's where the y value is 0. That was probably the easiest way to find them without having to do a lot of stuff, because if you go to your calculator won't give you this answer because the square root of 3 is something like 1.7. And so does your calculator give you answers like to the point?
Yeah.
No. So you would have to do that. This would be the easiest way to find the x-intercept. And to me, the easiest way to find the y-intercept is to go ahead and FOIL this. If you FOIL x plus 4, well, that's x plus 4 times x plus 4, right?
Mm-hmm.
The first term will be x squared. The outside term is a 4x. The inside term is a 4x. And the last term will be a plus 16. Meaning you would have x squared plus 8x plus 16 minus what? 3. What could you put together? The 16 and the what?
So be 13.
So negative 3. So basically,
plus 13.
guess where the y-intercept is?
Right there, 8x.
At
13, I knew that.
13. Because if x is 0, you plug it in, guess what happens to all these numbers are going to go away, right? So the y-intercept occurs at, technically it's at 0 what? 13. And I think you write the x-intercept might really be written like this number, comma, 0. I would just take that though on the test,
Oh, okay.
you know, but I want to just kind of point that out. So that would be the answer to number 1, okay?
And then for the y-intercept, you said we could just type in the calculator, correct? And just
The y-intercept, you can definitely type in the calculator and look where x is 0. Or, even an easier way to do it, if x is 0, just what? Plug it in, right? What's 0 plus 4?
4.
4, what's 4 squared? 16.
16.
16 minus 3 is
13.
13.
Oh, yeah. Mhm.
That would even be what? Easier than doing, although this might help me out with some other problems, like if I need to find some other things, but this particular one worked out like the following right there, all right? So that was how I would do like problem number 1, all right, which is in a sense finding the vertex, the x-intercept, and the y-intercept. So let's look at problem number 2. 2 has x squared plus 3x plus 1/4. Now, one thing we could do is we could complete the square. I'm going to show that, and then I'm going to show you another way to even do it that's even easier, I think, how I would probably do it on the test. But first off, completing the square is there an a term here? No. No. So remember what we used to do is this here, we would take that x squared plus this 3x and kind of make a space. And we look at this number right here. If there was an a term here, I'd have to divide by that, but I don't. And I come over here. What is 3 divided by 2?
2.
Yes. You're always going to take this middle number and cut it in half. Because to complete the square, remember how like the last, this number here is going to always be doubled. If you add it and double it, you get back to this right here. So if I take 3 divided by 2, and do 3 divided by 2, add it together, you get back to 3, right? And then we take this number and we square it, which gives me 9/4. 3/2 squared is 9/4, all right? So what I'm going to have to do now is this. I need to add 9/4 and subtract 9/4. Remember? And then we were like the country club. We're going to kick out the negative person, right? There's no value in front of this one. Like if there had been a 2, I would have to take 2 times that to kick it out. There's not, so I can just kick this one out very simply. Negative 9/4 plus 1/4. Right? Now I can put, what's negative 9/4 and 1/4 when put together make? A negative 8/4, which is the same thing as what? Negative 2. And guess what happens to this? This is going to, I did completing the square so that I could purposely do this right here. This will be x plus, guess what? What number do I have right there? Whatever this is divided by 2.
Why would? No.
No. To complete the square, whatever this is divided by 2 is what goes right there. So guess what? I now have it what? I now have it in completing the square form, right? So my vertex is at the point what? Negative 3/2, because it's an inside liar, right? Minus 2. There's the vertex. The easiest way to get the x-intercept is now take this and what? Make it a 0. So if I go 0 equals x plus 3/2 squared minus 2, well, guess what I'm going to do first? Add what? Add 2, right?
Mm-hmm.
Add 2. So 2 equals x plus 3/2 squared. Square root each of these, right? Plus or minus the square root of 2 will equal x plus 3/2. And now I need to minus that 3/2 over here. Kind of running out of room. So I'm writing small, I get negative 3 halves plus or minus what? The square root of what? 2. There would be my x-intercept. That's the x-intercept. And how can I find the y-intercept? The y-intercept's already done. Go up to the very beginning problem.
1/4 of it.
It's 1/4. Because if I make these 0, what's left?
Okay.
1/4. Now, that would be like the harder way. You know, how many of y'all, like completing the square is the hard part of the problem, right?
Mm-hmm.
You want to find
I
an
don't know what
easier...
your steps are.
Huh? The big thing is, like, going back over is completing the square right here. You have to separate these two. Let me show you
Wait,
what...
why does it go 3x plus 9/4 to 3 plus 3 halves?
Oh, right here. If I foil this, guess what it gives me? This.
Oh.
I'm purposely picking, in other words, I am purposely picking a value here that will make this a perfect square. Okay? If that's exactly what you're doing. And the way you find it, it's this number divided by 2 is the number you got to square to make the perfect square. Because remember your...
-2 is 8/4.
And negative 8 over, yeah, and this has negative, just negative 2. Now, you want to know an even easier way to find the vertex? The vertex, and I showed this the other day, is the x value of the vertex is at negative b divided by 2a. Remember, ax squared plus bx plus c, right?
Mm-hmm.
What is the b value here?
3.
So make it what? Negative 3 divided by 2 times,
2.
and
0.
no, not 0.
1.
Technically that's a 1. So the vertex is at negative 3 halves. That's a whole lot easier, isn't it? Now here's a kicker for you. If the vertex is at negative 3 halves, how can I find the y value for negative? Just go back to the equation and what? Plug it in, and if I had plugged in negative 3 halves here and squared it, plus 3 times negative 3 halves, plus 1/4, guess what I'll end up with as an answer?
-2.
Negative 2.
Dude, I get that.
Now, here's the key. What way's easier?
Plug it in the calculator.
Yeah, doing the negative b over 2a and then plugging it in the calculator is a lot easier, right?
Wait, I just plugged in the x plus 3 halves squared minus 2.
Just make sure that when you put this in the calculator, that you definitely put this in what?
Parentheses.
Parentheses. You'd replace the x with the what? Parentheses, in order to plug that in. Because then you
I
get
just put x, like parentheses x plus 3 divided by 2 parentheses.
Yeah, okay. You would, I don't think you would never hit. To type it in, if I was going to type in the calculator, I would go parentheses, negative 3 divided by 2, close parentheses, squared. Plus 3, parentheses, negative 3 divided by 2, plus, and I would do 1 divided by 4 in parentheses also.
Why?
We found -3, like, he found it up there. When you do negative b divided by 2a, you plug it in, and then you just put that in parentheses.
Whatever you get when you take this negative b divided by 2a, that's the same thing as doing, well, notice, this here is a shortcut to getting to here.
Yeah, so why couldn't you just type that into the calculator?
Type which one here?
That one.
This?
Yeah.
You could, but what I'm saying
And I
is...
did, and I got 0 and 1/4 as my...
Oh, your y-intercept?
Yeah.
Yeah,
That's
you can
right.
do that, yes.
Okay.
But however, the y-intercept you didn't even have to do because if you go back to the original problem, the last value is going to be the what? Y-intercept. So having said that, okay, wait a second. Yeah, because you didn't like. So let's do this here. So that was problem 2, right? X-intercept, y-intercept. So let's think of this here and think of this shortcut for the third problem here. Let's do this. And we'll do it completely shortcut method, which is the way I would probably do it on the test. Problem 3 is this. F of x equals negative x squared plus 2x plus 5. Here's how I would work this. Okay, first off, I know this is not going to factor, all right? I mean, so what I'm going to do is this. First off, I know the y-intercept already. There's 3 answers you got to come up with, right? Vertex, you got to come up with vertex, X-intercept, and y-intercept. I already know the y-intercept. What is the y-intercept?
5.
It is 0, 5.
5.
Because if I put zeros in here,
Mm-hmm.
I mean, the y-intercept's easy. It's just that last what?
Just the last number.
Turn.
Mm-hmm.
I'm going to cheat. I'm going to go ahead and I'm going to find the vertex by using the negative b over 2a.
And just plug
Because
it
to
in.
me that's a lot easier than completing the square.
Oh yeah.
So I'm going to go take this 2 and make it what?
Negative.
Negative. Divided by 2 times, and this is a
1.
negative 1.
Mm-hmm.
Well, that's going to be negative 2 over negative 2, which is a what? Positive what?
1.
So I know the vertex is at 1 something. Well, the easiest way to find the vertex would be go what? Just what?
Plug it in. Plug it in.
That's it. Plug it in, plug it in. Now, this means take 1 squared and make it negative. And if you're going to go to your calculator, you can type everything exactly the way it is, except where the x is, make a parentheses, and plug in this value.
Okay.
This will be negative 1, because 1 squared is 1, make it negative, plus 2 plus 5. Well, negative 1 plus 2 is 1, plus 5 makes this equal to what? 6. So the vertex is at 1, 6. The vertex is at 1, 6. All right? Now, you want to know another simple shortcut? Go back to standard form, right? What is the a value?
Negative 1.
So to write it in standard form, negative 1, the a value, same a value, they got to be the same, right?
Mm-hmm.
Times x, what's my h?
1.
This is hk right here, right?
Yeah, so 1.
But when we plus 1, I'll have to write it what?
Minus 1.
Because it's opposite squared, and the k is the same plus 6. So now I've written it in this form, right? I can find my x-intercept really easy, because now this is the same thing as the f of x being what? 0, right? So first off, what I might do is this. I might minus 6 from each side.
Mm-hmm.
Minus 6. So I have negative 6 equals negative 1. Guess what I would probably do now? Divide everything by negative 1. Because I need to get rid of this here.
Mm-hmm.
Divide by negative 1. What's negative 6 divided by negative 1 is what? 6. Square root this to get rid of the square root, right?
Mm-hmm.
So I'm going to have, I'm just going to write it over here. I'll have x minus 1 equals plus or minus the square root of 6. So x will be what? Guess where the x-intercepts are at? 1 plus or minus the square root of 6. That is a lot easier way to do it than to, you know what I'm saying? I think completing the square is kind of hard. And I can complete the square by cheating, right? Use this negative b over 2a and help me find all the other stuff. So, okay, go ahead and stop it.